Hello guys, in this video we're going to see what the definition of RabbitMQ is, what are the advantages, what are the different use cases, and we're going to see real life examples. We're going to dive deep into it, and soon I'm going to upload another video in which we're going to implement RabbitMQ with Node.js. We're going to have different microservices communicating with each other using RabbitMQ. It's going to be very interesting, so stay tuned and like this video. So what is RabbitMQ? RabbitMQ is a message broker software. A message broker is a software that allows applications and systems to communicate with each other and exchange information. It's also known to be a message queuing software. We push messages to queues where they will be stored until they are processed or consumed. Let's see an example to better understand. Let's say we have two different microservices or applications that need to communicate to exchange messages between each other. RabbitMQ would fit in the middle. It would be the man in the middle. As we said in our definition, a message broker is what allows different applications to communicate to exchange messages. So it would make sense that RabbitMQ would be in the middle. Of course, it's going to use a certain protocol in its communication. Now let's take one step further and see some more technical terms. So we have a producer or a publisher. The producer produces the message to the RabbitMQ broker. If you notice, we have two different entities inside the RabbitMQ broker, which are the exchange and the queue. When the message is produced by the producer, it will first arrive to the exchange, and then the role of the exchange is to route that message to a specific queue. Now in this case, we're going to keep it simple and just have one queue, but in the different few slides, we're going to see more complex and realistic problems. So at this point, the message reaches the queue, and then we have one more player in this flow, which is the consumer, the application that is listening and waiting for the arrival of new messages. The consumer would be listening to a queue, and then as soon as a new message arrives to that queue, the consumer would receive that message. So again, as you can see from left to right, the producer produces a message to the RabbitMQ broker. The message would arrive to the exchange. The exchange has a role to route that message to a queue. And then any consumer listening to that queue is going to receive that message. Now let's talk a little bit about the different advantages that RabbitMQ provide. The first advantage I want to talk about is the flexible routing. So if you recall, I said previously that the exchange had the role to route messages to queues. As we have different types of routings, this helps us cover different use cases or real-world problems. So for a certain problem, we would use a certain type of routing. For another problem, we would use a different type of routing. And we will see the different types of routings in the next few slides. But this helps us cover different use cases. So this flexible routing feature is very helpful. The second advantage I want to talk about is the guarantee of message delivery. So let's say the producer produced a message, and then the message has been received by the exchange and then rerouted to a queue. Let's say our consumer is down for some reason. It's not live, it's not online. The good thing is that the message is going to be stored in that queue. It's not going to be lost. And the other good thing is that we can acknowledge messages, which means that we can send an acknowledgement packet to the producer so that it knows that the message has been delivered successfully. And that can be configured in RabbitMQ itself. That way, we can guarantee that a message is not lost, and we can also guarantee when the message is delivered successfully or consumed successfully by the consumer. The third advantage I want to talk about is the different libraries we have. RabbitMQ has libraries for different popular programming languages such as C#, JavaScript, Python, Java, Ruby, and so many more. So you can implement RabbitMQ with your favorite programming language. Also, RabbitMQ is fast and reliable. It supports asynchronous and synchronous tasks. Okay, so at this point, we know that an exchange routes a message to a queue. But how does the exchange know which message should be routed to which queue? Well, before I answer that question, I want to just point out one more thing, which is that the connection between the exchange and the queue is called a binding. So the queue is connected to the exchange through the binding. Now let's answer the previous question. How does an exchange know how to route or which message should be routed to which queue? Well, in RabbitMQ, we have 4 different exchange types. We have the Fanout exchange, the direct, the topic, and the headers. And each type has a different behavior. Based on this type, the exchange would know how to direct messages. We're gonna go into details for the first 3 exchanges. So let's go ahead and start with the Fanout exchange. Let's take a look at this Fanout exchange example. So far, we know the producer, we know the consumer, we know the exchange and the queue. The only difference here is that we have multiple queues, and this is the case for any other like RabbitMQ example. It's not necessarily just related to the Fanout exchange. From now on, we're gonna use different queues in our examples, more than one queue. So here we have 3 different queues. We have an exchange, which is of type Fanout, and of course, the connection between the queue and the exchange, just as a reminder, is called a binding. Now here, the producer sends a message to the exchange. The exchange, being of type Fanout, is going to route the messages in a way that every single queue that is bound to that exchange, so every single queue that has a connection, a binding with that exchange, is gonna receive that message. So you can think of a Fanout as a broadcaster. It broadcasts its message to every single queue connected to that exchange, which is why, if you take a look at the graph, the message in yellow is delivered to every single queue that has a connection or a relation with that exchange. And then we can see that every consumer is listening to a certain queue. You can think of the consumers as different microservices or applications, and each is listening to one of those 3 queues, waiting for a message to be sent. Let's take a look at this real-life example. So here we have a transaction service, which is the producer or the publisher, and the message being published is the transaction details. So let's take a look at how the schema was. As you can see, the transaction service is the producer and the message being sent is the transaction details. The transaction details might contain information such as the transaction ID, the amount, the description, the name, and so on. So once the transaction service produced the transaction detail message, the exchange is going to receive it, and then the exchange, being of type Fanout, is going to broadcast that message, that transaction details object, to every single queue that has a connection with it. So every queue that has a binding to that exchange is going to receive that message, because that exchange is of type Fanout. In this case, we have 3 different queues, just like before. We have the SMS queue, the email queue, and the PDF queue. And yeah, as you can see, I have noted down the message in yellow, so you can see that this message has been sent to every one of those those 3 different queues. If you take a look at the right as well, we can see that we have 3 different services, which are the consumers. We have the SMS service, the email service, and the PDF service. Each one of those 3 different services playing the role of a consumer, so they are consuming the data being sent, and of course, each one of those 3 different services is listening to a specific queue. So the SMS service, for example, is listening to the SMS queue. This is a very realistic problem because in real life, usually, if you have a bank account and a transaction happens, multiple things would happen, like you would receive an SMS on your phone, you would receive an email message notifying you, and so on. And of course, our system here is made of different microservices. Every microservice takes care of one action. So it's not a monolithic application in this case, it's a microservice-based application, which is why we have 3 different services. We only produced the message once, the transaction service only produced the transaction details once, and then every single microservice received that message on a certain queue, listened to it and received it, and then they behaved in a different way based on what the purpose of that microservice is. So for example, the email microservice is the one that takes that transaction details and then sends those details notifying the user that, hey, your transaction was successful, this much was deducted from your account, and so on. I hope this example was clear. Now, let's take a look at the direct exchange. Like before, we have the producer, we have the message being produced, we have the RabbitMQ broker, which contains the exchange and the queues, and we have the consumers that are listening to queues. However, this time, if we take a closer look at the message, we can see that we have an extra attribute, which is called routing key, which has a value of high. To understand what the purpose of this routing key is, which is attached to that message, let's take a look at our bindings. Again, a binding is simply the relationship or the connection, which is annotated by the arrow here, between the exchange and the queue. It just means that, for example, QA is interested in messages provided by exchange, which is this exchange. We haven't named it, of course. In real life examples, we would name that exchange. It would have a name. We can also see that every single binding here we have has an attribute called binding key. For example, the binding on the first key, on the first queue, so Q1, is bound to the exchange with a binding key of hello. Q2 has a binding key of hey, and Q3 is bound to the exchange with a binding key of high. Now we can see a pattern here. We can see that our message has the attribute routing key of a value high, and the Q3 is bound to the exchange. The binding itself, the connection itself, has a binding key of high, which is similar. It matches the routing key of the message. Which is why, if we take a look here, we can see that the message is only being sent to Q3, not to Q1, not to Q1, not to Q2, just to Q3. And if we take a look here, the third consumer, the one at the bottom, is the only one being notified of the message, because the exchange, the direct exchange, looks and tries to match the routing key with the binding keys of the queues it's related to or is connected to. It takes a look. The routing key of that message is high. Does it match binding key hello? No, so it doesn't send the message to Q1. It does the same for every single queue. It finds that the routing key of the message, which is high, matches exactly the binding key of Q3, which is also high, which is why the message has only been routed to Q3, and the consumer, of course, has been notified because it's listening to that queue. One more thing which is worth noting, if you remember the Fanout exchange, here we're not sending a routing key. However, if in your application you had an exchange of type Fanout and you have added the attribute which is routing key to your message, well, if the exchange is of type Fanout, then it will just simply ignore that routing key which is provided on the message. It will just ignore it completely, and just like we said previously, the exchange of type Fanout would broadcast the message to all the queues that are connected to it or bound to it. So the routing key would just be ignored in the case of an exchange of type Fanout. It will only be taken into consideration in exchange direct, as we have seen now, and as we will see later on, it will also be important in the case of the exchange of type topic. Let's see a more realistic example. Here we have a producer, which is a logger service, and then this logger service is going to produce logs, log details. It can have the log information, the timestamp of the log, different things, where this log is coming from, like which function produced that log, which action produced that log, so on. We also have three different queues, a warning queue, an error queue, an info queue. We have three different services. Warning service, which takes care of warnings. It's only responsible for warnings. Maybe it saves the warning to a database, maybe it sends it to a third party, maybe it sends an email, it doesn't matter. The error service is responsible for taking care of errors as well. It might be saving those errors in a database, it might be taking those errors and maybe storing them somewhere else, doing something with them, getting statistics, it doesn't matter. The info service is also a third microservice which only takes care of info logs. We can also see that our log details, which is the message produced by our producer, which is the logger in this example, has a routing key attribute, which has a value of info. And the exchange is of type direct. And like we said in the definition, the direct exchange takes a look at the routing key of the message and tries to match it with a binding key. And whenever there's a match, the exchange is going to route that message to the queue that has a binding key which matches that routing key. In this example, the warning queue, for example, is bound to the exchange with a binding key of value warning. The error queue has a binding key of error, and the info queue has a binding key of info. So, based on the definition, we can see that the routing key and the binding key, the routing key of the message of the log details being sent, which is info in this case, is matching with the info queue binding key, which is info, which is why the exchange has redirected or has routed that log detail, that message, to the info queue. And this is why the info service is the only service receiving the log details in this specific example. That way, the logger did not have to worry about where to send that message to which service. RabbitMQ is the one who took care of that. RabbitMQ received that message. The exchange, based on the type, which is direct, and based on the routing key and the binding keys, was able to match and to know which microservice or which queue should be provided with this message. And then the microservice, of course, listening to that queue, is the one who's gonna get that detail, get that log detail, and then do whatever it needs to do with it. Either save it in a database, send it somewhere else, do anything with it. The last type of exchange I want to show you in this video is the topic exchange. So we have here a vehicle producer that produces vehicles, let's say. We already know how this works. We have a producer producing a message to the topic, to the exchange, I mean. The exchange, based on the exchange type, would route the message in a certain way to certain queues, and then we have the consumers or the services. So here, our consumers are the three different services: BMW bike, Ferrari, and all cars. And if we take a look at our message, we can see that our routing key contains dots: Ferrari, dot car, dot blue. We use dots with the topic exchange type to create patterns. If we take a closer look, we can see that the first word used, which is Ferrari, is a brand, is a car brand. The second one is the vehicle type, so it's car, it's not plane, it's not boat, it's car. The third one is used to annotate the color, blue, for example, here. It could be red, it could be any other color. So this is used, the topic exchange is used whenever we have patterns. We use it to match patterns. Unlike in the direct exchange, where we match the same exact word. Here, we can use wildcards such as the star, which can be substituted for exactly one word, and the hash, which can be substituted for 0 or more words. To help you understand more, let's take a look at Q1. The binding key is bmw.bike.star. So the last word, instead of using an actual word, we used star, which is a wildcard. That means we can substitute with one word. So it could be bmw.bike.red, bmw.bike.blue, bmw.bike. Literally anything. This would cause the exchange to route the message to Q1 if we had a routing key of bmw.bike. One word only, and this word could have any value. The second queue, for example, which has a binding key of Ferrari.hash, needs to have the first word as Ferrari, and then Whatever after that doesn't matter, because the hash means that we can substitute that word, or we can substitute here or put here anything from 0 to infinitely any number of words. So we could have Ferrari, it would go to Q2. We could have Ferrari dot plain dot red dot anything. We could have as many dots after Ferrari, as many words after Ferrari. We could also just have Ferrari. It just needs to match the first word, because the hash wildcard mean that we can substitute that for 0 or more words. The third queue has a binding key of star.car.star. So we only need to have car in the middle, and then the first and the last word can be any word. It's a random word, but it has to be one word. So we can't, for example, have red dot something dot car. No, we only need to have exactly one word before car and exactly one word after car. So for example, we could have Mitsubishi.car.purple. It would go to Q3. Let's take a look at the actual value that we have in our routing key. In our case, we have Ferrari.car.blue. Let's take a look at Q1. The binding key is BMW.bike. We can see that the pattern does not match. We do not have BMW.bike in the routing key. In the second queue, also, by the way, I've made a small mistake in the binding key. Ferrari should be a small f, not a big F. If it was a bigger F, it wouldn't have matched it. The message wouldn't have been sent to Q2, as I have shown it here. So please keep it in mind. F here should be lowercase, or else it would not match and it would not route the message to Q2. So let's assume it is a small f. In our case, let's compare the patterns. The message, the routing key is ferrari.car.blue. So we have the word Ferrari at the beginning, and then in the binding key we have a hash, which means we can have any word or any number of words after Ferrari. In this case we have car blue. Since the first word match with a pattern, then the message will be sent to Q2, and then the Ferrari service is going to receive that message. Now let's take a look at Q3. We have star.car.star. In the message we have Ferrari.car.blue. If you take a look, car matches car in the middle. And then the star, which means that we need exactly one word, which is random. So Ferrari and blue, those are one word before and one word after car. So the pattern is met. We have matched the pattern. So we can say that the vehicle exchange is going to send that message, it's going to route it to Q2 and to Q3 because it matched both those patterns. But it's not going to send it to Q1 because there's no match in the patterns. I hope this was not too hard to understand. I know the topic exchange is a bit more difficult to grasp at first than the other exchanges because it's not as straightforward as the others, but as you practice it, as you read more about it, you'll get more comfortable with it. There's also a few more use cases in which we can use RabbitMQ for. I'm not gonna go too deep into them. Just quickly, there's worker queues in which we have different workers listening to the same queue. It is used to distribute time-consuming tasks among multiple workers. And we also have RPC, which is remote procedure call. So in the examples before, in every example before, we used to produce a message and then not wait for a response or a reply. Here in RPC, we produce a message and then we wait for a reply. You can think of it like an API call when you make a call and then you wait for the response. So here, for example, for the request, you can pass in an attribute, the reply to, and you pass in the name of the queue that is going to be responsible for the replies, listening to the replies from the consumer. If you want to know more about those, feel free to Google it or go to the documentations. Thank you for watching. Please, if this video was helpful, like and subscribe. I'm gonna upload a video soon in which I'm going to use the direct exchange type and reproduce the log example that we've seen. So we're gonna create multiple microservices in Node.js and use RabbitMQ. Thank you for watching. Please like and subscribe, and if you have any feedback, let me know. Thank you.